All right, moving on now to example number 4. We're going to be solving an area problem. So let's check out this guy, and of course it's all related to quadratics in some way or another. So a football field, a practice football field, is 30 yards wide and 40 yards long, and a strip of grass of sod of uniform width, which is uniform, just basically is the same width, is to be placed around the perimeter of the practice field. Now, there's enough money budgeted for 296 square yards of sod. How wide will the strip be? All right, so we always want to start with what is our variable and all that kind of stuff there. So let's just start with that, because every word problem always start with what is our variable. So we're going to let x equal how wide will the strip be, so the width of the strip. Okay, so the width of the strip. The width. Sorry there. I'm finding a little bit of a cold right now. You could probably hear a little bit in my voice, but we got this, y'all. All right, so we should probably draw a little football field. Kind of good to have little pictures here and a little diagram as we do this. So let's draw a little football field. So I'll draw a little rectangular field here using these tools I have on my cool program. So something like that there. Okay, so there's our football field, and of course, you know, we've got the lines going across, right? You know, cool. So the football field is 30 yards wide, so we know that this right here is going to be 30 yards, and that's from here to here. And the length of the football field is 40 yards. 40 yards. 40 yards, and that's going to be from there to there. Okay. Now a strip of grass, sod of uniform width, is going to be placed around the perimeter of the field. So that means there's going to be a strip of grass that's going to be placed around the field. Okay, that's a nice little strip that goes all the way around. And they only have enough money for 296 square yards of sod. And we want to figure out how wide should the strip be. Okay, so looking at this now, let me just draw another rectangle around our football field, because that's what it's kind of like what it's going to do there. It's going to be some strip of grass that's going to be all the way around our football field, and it's going to have the exact same width, and that's why I said it's a uniform width. Okay, and make that a little neater there. Okay, so this is all going to be grass right here. Okay, we could like highlight this row here. Well, maybe make it a little bigger there. Okay, so this is all going to be grass right here. All this guy, beep 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 beep. All this is going to be grass. Okay, and they want to have the same strip all the way around the practice field. Okay, so the question is, what's the width of this? How wide will the strip be? So that's what we're trying to solve for. That's what x is. So I'm going to just put, okay, this right here is x right here, from here to here. And then x is also from here to here as well, from here to here, right? I mean, they're both the width right there. So the width is right here, width is right here, width is right here. What is the length of this width? Okay, so let's see if you can follow this logic here, because this kind of has different parts here, but let's just think about the big picture. If we know the big area, the area of the whole entire rectangle, meaning including the strip, so the big area, if I know the area of the big one, and then if I could find the area of the smaller rectangle, which is the football field, I can subtract those two areas, right? I can subtract those two, and that's just going to give us just the grass, and we can make an equation to have that. So basically, I'm going to do the big area minus the small area. And that has to be equal to the amount of sod that we're able to lay down, which is going to be the 296. So the big area, we need a length and we need a width, right? Well, check this out. So this length right here is x, this right here is x, and this right here is 40. So x plus 40 plus x is 40 plus 2x. Okay, so this is x, and this is x, and then you add the length of the field, that's going to be 40 plus 2x. Now the width of the field, x plus 30 plus x. So that's 30 plus 2x. So the big area, the whole entire area, is going to be the length times width, right? I mean, that's just the area of any rectangle. So this area right here is going to be the length. So 40 plus 2x times the width, 30 plus 2x. All right, and so that gives us the entire area. Now let's subtract the small area, which is 30 minus 40. 30, I'm sorry, not 30 minus 40, 30 times 40. And that should all equal the exact amount of sod that we have the money for, and we're able to lay down 296. Okay? Whew. So all that, we were able to set up an equation. Now we got to go ahead and solve. So we're going to go ahead and use some FOIL method, and we're going to go from there. All right. So here we go. Using the FOIL, 40 times 30 is 1200. 40 times 2x is 80x. 2x times 30 plus 60x. 2x times 2x plus 4x squared minus 30 times 40, 1200, and that all equals 29.6. All right, so now we have to solve for x here. Well, the 1200 and the 1200, they cancel out because we have a positive 1200 and a negative 1200. I can add the 80 and the 60 together right there. So I'll have 4x squared plus 14x equals 296. Okay? Now let's write this in standard form because I want to be able to, I mean, this is going to be pretty big. I probably won't even try to factor this, but maybe we can use the quadratic formula. So let's subtract 296. And I get 4x squared. Let's see, 14. Oh, yeah. So 14x minus 296 equals 0. All right. Quadratic formula has been very, very, very handy. We can solve all these kind of quadratic problems now. So let's go ahead and plug it in. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. Let's go ahead and plug this guy in now. All right, so we're going to plug in our a right here. This is our b, and this is our c. Our b right here is 14. Our b right here is 14. Our a is 4. Our c is negative 296. And our a here is 4. All right, most definitely bust out your calculator. Negative times a positive is a negative 14. So plus or minus. All right, so I'm just going to straight just do this whole thing into my calculator right here. I'm going to put 14 squared minus 4 times a negative 296. And you might want to try that to see if you can get this number. And I got 24,336. Just doing straight calculator right there. And that's all over 8. So see if you get that, okay? Keep on going here. We get negative 14. And it just so happens that this is a nice radical number there. Probably don't have that one memorized, but that's actually 56 squared, so that's 56. The square root of 24,336 is 56 all over 8, which means now we have our two answers. We have negative 14 plus 56 all over 8, and then negative 14 minus 56 all over 8. So this guy right here is going to give us 2. Put that in your calculator. This right is going to give us a negative 37. Okay, and again, we were solving for x, right? And x stood for the width of our strip. Okay, distance can never be negative, so we could be like, no, homeboy, and cross out that dude. okay, because in the context of the real life problem, distance cannot be negative. So that means that the width right here has to be 2. And it has to be 2 what though? What's our unit of measure? And it looks like we are in yards. So our answer is 2 yards. And I do suggest that probably this one example is nowhere nearly enough. I would probably look at the example also in the textbook and also look at the additional videos that are provided by the textbook company.